ice. Ice starts to melting, and this rise in temperature, the thermometer shows rise in temperature. Up to what time? When the temperature in thermometer reaches to 0 degrees Celsius, it remains constant. Till that time, when this ice completely doesn't melt and convert into water. This is, we have studied, this is the latent heat. And then again we also have seen, when this ice completes melt and converts into water, then this temperature shows thermometer shows rise in temperature. Now this rise in temperature reaches up to 100 degrees Celsius. At that time it again becomes steady, and till complete water evaporates, it remains constant at 100 degrees Celsius. This we have studied. And this heat absorbed by heat and water at constant temperature to convert their states. This is called as latent heat. Now we are going to study, there are two types of latent heats. First, latent heat of fusion. Now what is this latent heat of fusion? It is the heat absorbed by ice till complete conversion into water. What heat is absorbed by the ice to change its state from solid to liquid. It's called as latent heat of fusion. Means what? What is the latent heat of fusion? It is the heat absorbed by a substance to convert solid into liquid. Then what is the actual definition of latent heat of fusion? It is the heat absorbed by a 1 gram of solid to completely convert into liquid. That heat absorbed by the solid is called as latent heat of fusion. Now, second is latent heat of vaporization. Now our second part of this experiment was when completely ice melts into water. Then again this thermometer shows the steady temperature at 100 degrees Celsius till completely evaporation of that water. Means what is the latent heat of vaporization? It is the heat absorbed by liquid substance to convert this liquid state into gaseous state. What is the actual definition of latent heat of vaporization? It is the heat absorbed by 1 gram of liquid substance to convert into gaseous state. So thus we have studied what is the latent heat, what is the latent heat of fusion, what is the latent heat of vaporization. Now we have to study about the graph. When we draw a graph of volume of substance, any, either liquid or solid, versus temperature, then we observe it is continuously, it is straight line. Now our next point is regellation. What is this regellation? We know when a solids are pressurized, the solids are converted into liquid. Means we can convert the states of matter applying the pressure on it. According to that, when we apply pressure on the ice, then it should be converted into water. And same we are going to see with the help of an experiment. Now, in this experiment there is a table. On that table we have taken an ice cube. And we have applied the pressures by both the sides to that ice cube. We have taken two weights with the help of thread, and we have to keep, suppose this is the ice cube, then we have to keep the thread in this way, and we have to apply the weights in this way. What happens when weights are applied, when thread remains on the surface? The pressure is applied on the surface of ice cube, then this thread is inserted into the ice. How does it happen? Because due to this pressure, the pressure is applied on the surface of ice cube, and on this place where thread is situated, when thread is placed at this place, the ice converts into water, and this thread is inserted into the ice cube. As soon as pressure is released, upper surface of ice cube again we convert into ice. In this way, thread is inserted due to this, with the help of this pressure, into the ice cube, and then also ice cube is not broken. So this tendency of the ice is called as regellation. Now we have to study about the separate special character given to the water. Now what is its aim? Why nature has given this special character to the water, we will see afterwards. But what is this special character of the water, we will see with the help of this Hope's apparatus. This is called as Hope's apparatus. In this apparatus, one jar is inside, in between. Now, at one place of the jar, a trough is placed. Actually, it is composed. The trough is composed, and this jar. Why this trough is there? We have to place in this trough this freezing mixture, and we have to take the water in this jar. When we take this, due to the freezing mixture, what happens? The water inside the jar is cooled down. Its temperature of that water in the jar is reduced. And as we know, when the temperature is reduced, at that time density is increased. Volume decrease and density increases. The same thing happened with this water. Due to this freezing mixture, the temperature of water inside the jar decreases. As the temperature decreases, its volume decreases, as well as density increases. As its volume decreases and density increases, due to the increase in density, this water goes at the bottom of the jar, and this water comes up. Again, same procedure is repeated till the water occupies the place below the trough of freezing mixture. Now, when water occupies the total place under the freezing mixture, under the trough of freezing mixture, the temperature of water remains constant, that is 4 degrees Celsius. Now, after this, the temperature of water starts to decrease again. When this temperature of water decreases below 4 degrees Celsius, at that time, what happens? The density of that water and volume increases. Now you see, you remember, you listen. When the water acquires the temperature of 4 degrees Celsius, its density decreases as well as its density increases as well as volume decreases. But when the temperature of water decreases below 4 degrees Celsius, the density decreases and volume increases. As density increases of that water, this water is moved at the upper portion of this jar and it goes above the trough due to the less density. When it reaches here at the above portion of the jar, it acquires the slowly, gradually, the temperature further decreases, temperature of water further decreases and it acquires 0 degrees Celsius. As soon as this water acquires 0 degrees Celsius, it converts into ice. Means now after some times we will see in this jar, the upper portion of the trough, above the trough in the jar there is the ice and in the jar below the trough there is the water. And this water constantly remains of 4 degrees Celsius. And upper portion of jar is of ice, that is of 0 degrees Celsius. Now this special behavior of water, other liquids doesn't show this behavior. This special and specific behavior of water is called as anomalous behavior of water. Now why this nature has given this special character to water? We know there are aquatic animals. In other liquid no animals live. And only in water animals are present. Aquatic animals live in water. Now you imagine, suppose this behavior was not given by nature to the water. What would have happened? All the aquatic animals would have been crushed. And due to this aquatic animals, the nature has given the special character to the water which is called as anomalous behavior of water. Now what happens? What is the natural application of this? Natural application of this is in the reservoir, in water reservoir, the aquatic animals live. And these aquatic animals, in the winter there are some areas in which the atmospheric temperature falls below 0 degrees Celsius. Now it was very terrific condition for the aquatic animals, but due to this anomalous behavior of water, what happens? When water acquires the temperature of 4 degrees Celsius, at this temperature the water has highest, greatest density and therefore it goes down. And as the temperature of water decreases below 4 degrees Celsius, when it goes below 4 degrees Celsius, it becomes lighter in weight due to the decreasing density and it comes upside. As it comes upside, when it reaches 0 degrees Celsius, the total upper surface of that reservoir converts into ice. And we know there is the tendency of ice. Ice has one characteristic, that ice doesn't allow heat to transport. Heat doesn't allow to heat either outside or inside. Means actually the outside layer is colder than downside of the ice. And this ice doesn't allow to remove to transfer of heat from below side water to the atmosphere. And due to this, what happens? The upper surface in winter season, upper surface of reservoir remains of ice and downside it is the water. Means aquatic animals can relax or smoothly they can live their lives. Here we have completed. Now today, in this today's period, we have completed what is the latent heat of fusion, what is the latent heat of evaporation, what is the regellation, and what is the anomalous behavior of water.